Good afternoon. On behalf of the India International Center, it's my privilege to extend a warm welcome to our distinguished speakers, the author, esteemed members of the scientific and academic community, and all our guests who have joined us this afternoon. The India International Center has for over 6 decades served as a meeting ground for ideas where scholarship, science, literature, philosophy, and public discourse intersect. Today's discussion continues that tradition by bringing together eminent scholars from diverse disciplines to reflect upon a question that has fascinated humanity across civilizations. What's the nature of reality? Albert Einstein once remarked, the most incomprehensible thing about the universe is that it is comprehensible. Yet modern physics has repeatedly reminded us that reality often resists our deepest intuitions, quantum uncertainty, relativity paradoxes, and the limits of observation compel us to rethink what we know and perhaps more importantly, how we know it. It is precisely this intellectual adventure that lies at the heart of the universe is pranking us. Dr. Mrittunjoy Guha Majumdar invites readers on a stimulating journey where physics meets philosophy, certainty gives way to curiosity, and contradictions become gateways to deeper understanding. Rather than presenting uncertainty as a weakness of knowledge, the book celebrates it as one of the greatest strengths of scientific inquiry, a reminder that every discovery opens the door to new questions. Today's distinguished panel represents an extraordinary spectrum of scientific excellence, bringing together expertise in physics, nanoscience, molecular biology, chemistry, atmospheric science, science education, public engagement, accelerator physics, and philosophy of science. Their collective insights promise to enrich our understanding of the ideas explored in this remarkable book. We are honored to welcome Professor Ajoy Ghatak, one of India's most celebrated physicists and educators, a pioneer in optics and photonics, former president of the National Academy of Sciences and recipient of the Shanti Spuruk Bhatnagar Prize and numerous international awards. Professor Ghatak's pioneering research and authoritative textbooks have shaped generations of physicists and engineers in India and across the world. Welcome, Professor Ghatak. Our next distinguished speaker is Professor Avinash Pandey, Director of the Inter-University Accelerator Center, an eminent physicist and academic leader. He has made significant contributions to nanoscience, material science, atmospheric sciences, and accelerator-based research. His scientific leadership has played an important role in strengthening India's research infrastructure and fostering interdisciplinary scientific innovation. Welcome, Professor Pandey. We are awaiting arrival of Professor Anand Ranganathan, but meanwhile, where is he? Hi, Anand. Professor Ranganathan is professor at the Special Center for Molecular Medicine, Jawaharlal Nehru University, an internationally respected molecular biologist, author, and science communicator. Professor Ranganathan's pioneering work in protein engineering and directed evolution, together with his commitment to bringing science into public discourse, has earned him wide recognition. Welcome, Professor Ranganathan. Professor S.V. Iswaran is going to join us virtually, but it is my duty to introduce him to the audience. He is an emeritus professor at the Academy of Scientific and Innovative Research, a distinguished chemist, educator, and former head of the Department of the Chemistry and Dean at St. Stephen's College. Professor Iswaran has devoted decades to advancing chemical sciences by inspiring generations of students through exemplary scholarship and academic leadership. We are delighted to have Dr. Sumit Mishra is also not here, but he's going to be represented by somebody. I'm sorry, I don't. Onish, okay. Welcome, Onish. But I will introduce Dr. Mishra to the audience. He's been principal scientist at the CSR National Physical Laboratory. His research on atmospheric aerosols, environmental science, climate interactions, and atmospheric optics has significantly advanced our understanding of air quality, environmental processes, and climate science. Our distinguished panel also includes Dr. Arun Sikarbar, Associate Professor at the National Council of Educational Research and Training, a biotechnologist, educator, and accomplished science communicator. He has consistently worked to bridge cutting-edge scientific research with public understanding, making science both accessible and socially relevant. Welcome, Dr. Arun. We are equally pleased to welcome Dr. Kamalika Banerjee, Program Manager at the Foundation for Advancing Science and Technology, India. Trained as a biophysicist, she works at the intersection of science, policy, innovation, and public engagement, championing scientific literacy and evidence-based approaches for societal development. Welcome, Dr. Banerjee. Joining us is Dr. Sarvesh Kumar, Associate Professor in the Department of Physics and Astrophysics at the University of Delhi, an accomplished researcher in accelerator plasma physics. His work contributes to advancing experimental physics and the development of sophisticated scientific instrumentation and technologies. Welcome, Dr. Kumar. Finally, it's our privilege to welcome the author of the book, Dr. Mrittunjoy Guha Majumdar. Through The Universe is Pranking Us, he ventures beyond conventional scientific writing to explore the fascinating dialogue between physics and philosophy. His work encourages us to embrace intellectual humility, question familiar assumptions, and appreciate the profound beauty of uncertainty as an essential feature of reality itself. Welcome, Dr. Guha. Ladies and gentlemen, meaningful conversations often begin not with definitive answers, but with courageous questions. Today's discussion promises to be one such conversation, one that challenges established perspectives while inspiring fresh ways of thinking about the universe and our place within it. With these words, it's my pleasure to welcome you all once again to India International Center, and I wish the book very great success and all of us having a stimulating, through a thought-provoking and memorable afternoon. Thank you very much. Okay, we'll have the photo of formally launch the book.
Thank you.
Good afternoon, everyone. Before we proceed, I would like to request everyone to put their phones on silent mode. There is a quiet humility that every honest research for truth eventually teaches us. The farther we travel into the universe, the more we discover that reality is richer than our imagination, subtler than our language, and endlessly beyond the limits of any certainty. That is why the greatest discovery in science have never closed the book of wonder. They have only turned the page. The universe is pranking us grew out of that feeling. At its heart lies a simple question. Why is it that each time we think we have reached firm ground, the universe invites us to see things differently? It is a rare privilege to find oneself in the company of scholars, luminaries, whose lives have concentrated in the pursuit of truth. Though they have traveled different paths of inquiry, they are united by a common conviction that knowledge is a possession of certainty, but the discipline of seeking, not the end of wonder, but its continual renewal. May this be more than a launch of a book. May it be a beginning of a conversation that continues long after we leave this room.
Good afternoon to all. It is fitting that we begin with optics, for every search for truth begins with learning how to see. Through this pioneering contributions to optical physics and through textbooks that have shaped generations of physicists, Professor Ajoy Ghatak has taught us that clarity is not merely a property of light but also of thought. It is my great privilege to invite Professor Ghatak to inaugurate this conversation.
Thank you very much. Indeed, it's a great pleasure and privilege to be in this august company. I thank Dr. Mrittunjoy for inviting me to this beautiful session. And he had asked me to speak for 10 minutes, so I have prepared a 10-minute talk. So I will exceed my allotted 7 minutes by 2-3 minutes. You will pardon me for that. So I will start out by mentioning that very recently, one of my classmates in MSc and a very close friend, Professor Padmanabhan Krishna, delivered a beautiful talk on religion, science and spirituality. Professor Krishna was my classmate and we did MSc together from Delhi University and had teachers like Professor D.S. Kothari as teachers. And subsequently, he did his PhD at Banaras Hindu University, where he became a professor and also head. And then he was already a disciple of J. Krishnamurti, and he resigned from Banaras Hindu University and became a spiritual guru kind of a thing. And he spent his entire time with Krishnamurti Foundation. So I see in Dr. Guha Majumdar the type of traits that my friend Krishna has. He left physics and he joined. He has not left physics. He is a great physicist. He did his PhD from Cavendish Lab, but he is approaching towards philosophy and religion, the interplay of that. Professor Krishna in that lecture. So these are not my words. I am a simple physics teacher. So I have been teaching quantum physics to undergraduate and graduate students at IIT for a long time. So Professor Krishna said that religions got equated with belief, dogma, rituals and faith, thereby creating divisions in the world. In the West, the scientific discoveries of Galileo in the 16th century contradicted the beliefs of the Christian church. He believed that the earth went round the sun and not the other way around, and the church believed the other way around. And he was persecuted and forced to recant his findings. From that time onwards, there came a big divide between science and religion, which persists even today. And as most of you would know, on 17th February, the year 1600, Bruno was burnt to death by the church because he also believed that our earth went round the sun and not the other way around. And on 22nd June 1633, Galileo, who is often called the father of modern physics, was sentenced to imprisonment because his views were contrary to the Holy Scripture, and therefore he was required to reject, curse and detest his opinions. According to a report in New York Times, published in 1992, more than 350 years after the Roman Catholic Church condemned Galileo, Pope John Paul II is poised to rectify one of the Church's most infamous wrongs, the persecution of Galileo for proving that Earth moves around the sun. In fact, Albert Einstein had said, and this is very important, a conflict arises when a religious community insists on the absolute truthfulness of all statements recorded in the Bible. This means an intervention of the part of religion into the sphere of science. This is where the struggle of the church against the doctrines of Galileo. And about spirituality, my friend Krishna said that it was the quest for truth. And Dr. Majumdar is in a way like answering the same question. He did his doctoral work at Cavendish Lab and now he has written a very nice book on discovering the truth. That is what he has written. Later I told Krishna that all my life I have been trying to teach basic quantum mechanics, elementary quantum mechanics to undergraduate students at IIT Delhi, in which we try to know the fundamental particles like electrons, protons and neutrons and how they propagate, how they behave, how when you pass through two holes, how does the interference pattern come about. and they are the basic constituents of atoms, and therefore pursuing science, in my opinion, is also quest for truth and hence spiritual. Quantum mechanics is one of the most remarkable developments of the 20th century. It started with wave-particle duality, whether light is a wave or a particle, whether electron is a wave or a particle, and we now know the answer, as Feynman very beautifully says, that electron or proton or photon is neither a wave or a particle. Then what it is? Then it is described by the wave function psi, which is complex in nature, and which is the solution of what we call as the Schrödinger equation. And then Feynman also beautifully writes in his famous book that Schrödinger equation, where did that equation come from? And he writes beautifully that it didn't come from anywhere, it came from the mind of Schrödinger. That Schrödinger equation cannot be derived. So you see, but using this equation, he tries to find out, we can find out how the electron, which has a definite mass and a definite charge, can pass through both the holes at once. So if you have a beam of electrons passing through two tiny holes, and then on the back there is a screen, then you see a beautiful interference pattern. And so therefore you explain that by saying that the electron passes through both the holes at once, and that is what the wave function looks like. And how does the electron actually pass through both the holes? No one understands. So in fact, Feynman also writes that the two-slit experiment, the two-hole interference experiment, is the basis of quantum mechanics, and quantum mechanics is a subject that which no one understands. So quantum theory tells us that an electron passes through both the holes simultaneously. This is not the splitting of the electron into two halves, but only implies that if we wish to find out through which slit the electron passed, then half the time it will be found to have passed through slit number 1 and half the time through slit number 2. And it is the interference of the two which results in the probability distribution. So classical physics is deterministic in nature, and quantum physics is probabilistic in nature. And therefore, according to quantum theory, we cannot predict where exactly the electron will be detected on the screen. But if we carry out the experiment with millions of electrons, the intensity distribution, as predicted by the wave theory, will slowly build up. So in 1966, Richard Feynman delivered 6 very beautiful messenger lectures at Cornell University on the character of physical law. And in the 6th and final lecture, he spoke on probability and uncertainty, in which he said, electrons do not behave like particles, they do not behave like waves. Electrons in orbits are not somewhat like a cloud or fog of some sort surrounding the nucleus. It behaves like nothing that you have seen before. Well, there is one simplification: electrons behave exactly the same way as photons and protons. And Feynman also wrote that the double-slit interference experiment contains all the mysteries of quantum mechanics. So Dr. Guha Majumdar says that in his book on the universe is pranking us, is not here to give you answers, but to tell you the art of not knowing with grace. So we do not understand the quantum mechanics, but we use it. But we use it to predict very accurate results. Quantum mechanics happens to be one of the most successful theories of the 20th century. And it has given results which have been verified by experiments with tremendous degree of accuracy. So I will conclude by saying that in the preface of the book, Mrittunjoy writes, "What if everything you have told about finding truth is wrong? What if everything you have been told about finding truth is wrong?" That scares me, because although no one understands quantum mechanics, it is in a very beautiful discussion of Brian Greene with Nobel laureate Alan Aspect, they say that quantum mechanics has been unreasonably accurate, unreasonably effective, and unreasonably resisting all kinds of attacks. Indeed, this is what I've been trying to teach my students all my life. But then Einstein, when he was about 67 years old, wrote in his autobiographical notes that this double nature of radiation and of material particles is a major property of reality which has been interpreted by quantum mechanics in an ingenious and amazingly successful fashion. This interpretation, which is looked upon as essentially final by almost all contemporary physicists, appeared to me as only a temporary way out. So he says that quantum mechanics is still not complete, and there will be some other theory which we hope will make us understand everything from first principles. In his later years, Schrödinger integrated the philosophy of the Vedas and Upanishads into his scientific view of the universe. I told Krishna that Professor Krishna that he is our Schrödinger. In any way, I would like to mention that that by reading a part of Mrittunjoy's book, I feel that he is also a great physicist turned to a philosopher. Professor Krishna also mentioned something very profound. When you spend a lot of time learning science, you realize that we know very, very little. In spite of all our scientific and technological achievements, our knowledge of how this universe works, creation of life, etc., is minuscule. Therefore, studying science brings in humility. I conclude by saying that in India we have become a bit arrogant, and our education system should reach humility, compassion, and caring for others. In India, we have millions of very good and dedicated students who are waiting to be nurtured. What we require are teachers like Professor Hardy who nurture people like Ramanujans to his glory. We require more people like Professor Hardy today. So it is my great pleasure to read through this book by Professor Guha Majumdar, and I congratulate him for this great book, and which tries to bring in answers to very difficult questions that we physicists have. Thank you.
Thank you, Professor Ghatak. You have reminded us that every deeper understanding begins with seeing more clearly. If optic teaches us how to see, accelerator physics teaches us how to ask nature questions at energies and scales beyond ordinary experience. Professor Avinash Pandey's work has helped create the very instruments through which modern physics continues to explore the structure of matter. May I request Professor Pandey to share his reflections?
So, Professor Ghatak very nicely summarized some of the aspects of this book. The book Universe is Pranking Us generally talks about how universe we defy our rigid sort of human attempts, which we try to categorize or we try to come out at absolute logic. And he has also tried to look at this aspect, that how modern physics and Indian philosophical traditions, they all converge to non-dualism, absolutism. So Professor Ghatak was referring to Schrödinger. I come from Allahabad University, and Schrödinger was appointed there as physics professor.
President of our academy.
No, but he was also appointed as head of department, physics department. Why at that point of time he was trying to move to India?
Yes.
If you look at those aspects, he was moved by the concept of duality, which he very nicely included in his wave equation, that is putting E is equal to h nu and P is equal to h by lambda, wave as well as particle, both the things in one equation, and then he derived a new formalism which is known as quantum mechanics. So he very rightly pointed out that this Indian philosophy having those ingredients, and when I look at the way the Upanishads, they give those universal rules, it looks as if we are sitting in this room and there is a lightning somewhere, and suddenly we look at everything in one synoptic view. Whereas in modern tool, what we do, we develop some tool and then we discover some truth. Later on, we find that truth is not absolute. If we have discovered something bigger tool or more advanced, that tool looks as if there was something which was missing. So be it particle physics, be it any discipline, and he has tried to cover up many disciplines. Across the disciplines, he has tried to found how this non-absolutism is actually manifesting itself. So there is a kind of subversion of expectations. What we do, we develop a framework, and seemingly we try to capture the truth with the reality which is there with the help of the tools. We gather experimental evidence, and suddenly we contradict that whatever we have found is not the truth. So that means universe responds to our arrogance, which Professor Ghatak very nicely summarized, by revealing the non-absolute or paradoxical nature. So this book revolves around many such instances, and that makes you engrossed with the intricate details which are captured, which are summarized in many such instances. So illusion of determinism, that is another important thing, whether the universe is predictable or not. Quantum indeterminacy, uncertainty, that all comes into play. And then humility and wonderment. It is not that your arrogance is checked. Sometimes you become a kind of Vismayakari. Achanak you are in a Alice Wonderland. What has happened? What we have found, which was seemingly looked at if it is correct, but we have to go much more beyond that. So uncertainty as in inherent nature's law is the very essence that contradicts that theory of everything as is there, and we have to go beyond that. So many such experiments, for example, Michelson-Morley experiment, constancy of light by theory of relativity, Gödel's incompleteness theorem, quantum mechanics, moving from determination to deterministic physics to probabilistic, where contextual, paradoxical, and Professor Ghatak was nicely explaining about the experiment which Young's double experiment. There is an observer effect also. If you put detector, the electron becomes a shy element. So you don't get the diffraction pattern which was actually being depicted with the sort of wave nature. So that is another important aspect which has got some parallelism with our Indian philosophy, and for example this consciousness, if centric ontology, if you look at Vyavharik evam Paramarthik Satya, if you try to make a difference between that, you will look at that this becomes an important aspect of his book, which is very vividly and nicely captured. Another important thing which I found it very compelling to tell, there is a need for cognitive republic. Cognitive republic means that remains humble, maintains internal balance, and engages with contradictions. In geopolitical scenario, in social context, you see that everything is not black and white. If it is not black and white, this perspective prevents us from collapsing into a kind of crisis when faced with the contradictions. So tolerance is not the limit. Besides that tolerance, you should also have the skill to engage with, to learn more, and also to stay together in a kind of contradictions. In bio-absurdity, I will not touch that part because Anand is already there. He will speak in much more finer details. He can let us know. And the important thing is that we are all gathered to listen different perspectives, because different perspectives have been captured in this book. And the great divide of having on one hand general relativity, on the other hand quantum mechanics. Can we go for some kind of unification, the theory, that is the quest which we are following, which we are in the process of getting things done. So I have already completed my 7 minutes, so I'll pass it on to other speaker. Thank you.
Thank you, Professor Pandey. Your remarks remind us that every new instrument extends not only our reach but also our imagination. The search for reality is not confined to the cosmos, it is equally alive within the living cell. Through his pioneering work in molecular biology, from codon shuffling to infectious diseases such as malaria and tuberculosis, Professor Anand Ranganathan has shown how life's deepest questions emerge from its smallest structures. It is my pleasure to invite him to continue this conversation.
Good afternoon. Thank you so much. It's such an honor to be amongst all of you. And congratulations to Mrittunjoy for this wonderful book. Increasingly, when and what I speak is governed by two fundamentals that are very close to me, and they somehow form the extremities or they flank my reasoning. The first one is what the very famous philosopher Wittgenstein said, whereof you cannot speak, you should be silent. And the second one is what Guido in Fellini's 8.5 said, I have nothing to say but I'll say it anyway. So the first one I practice at home and the second one on television. So I'm kind of stuck in the middle out here, but I'm trying to make sense of the wonderful book that Mrittunjoy has written. But can I just say whatever I speak in the next 5 odd minutes would be, of course, appreciation of what you've written, but also appreciation of what you haven't written. As the very famous novelist Norman Mailer once said, the best book of mine is one that I haven't yet written. And the reason why I say this is profoundly perplexing to me how humans operate increasingly. I find it very perplexing, and I find it that yes, Mrittunjoy, you are right that the universe is pranking us, but I think where we get it wrong is that we are allowing ourselves to be pranked, if I can mutilate the word prank a little bit more. Because I think if we look at, and as biologists, as the previous speaker, Professor Pandey, attributed to me, my domain is chemistry and biology, so as whatever little knowledge we've gained from the fields of biology and chemistry, we now know, of course, not with certainty, but with increasing certainty as how we come to be here on Earth, how all life forms came to be here. And incidentally, it's amazing coincidence, just today on the front page of Times of India is a news about spud cell. I don't know whether some of you've... so scientists have created a cell completely in the lab that has completely synthetic cell that is able to replicate, that has genetic information, that has proteins, and increasingly it is a reflection of where biology and chemistry are going to take us. So when I say we are allowing ourselves to be pranked, it is based on the thesis that we are the only living species that I know that tries to reason things out, tries to explain, tries to write books, tries to attend conferences, tries to meet up and see why I know the reason for this, you don't, why I gauge your intelligence, you gauge mine. And the whole thing comes as a jolt to me at times, because since time immemorial, all living beings might have looked up at one point or the other and suddenly seen the sun disappear, the solar eclipse. But it is only the humans who wondered, why is it that this is happening? I mean, I've wondered, the dogs or the cows or all life forms or E. coli ever worry about why solar eclipse has happened? But it is only Aristarchus, I think his name was, 2,500 years ago, who correctly pointed it out remarkably well, that it is this amazing coincidence that the diameter of the sun is 400 times that of the moon, and the distance from the earth is also 400 times that of the moon's. And it is because of this coincidence that the moon is able to completely cover the sun. He provided a rational explanation. Why did he? I don't understand. And the reason for that is that now we know we can actually replicate life on Earth. From Stanley Miller's experiment of 1953, where he replicated the early Earth's atmosphere. Of course, he used reduced atmosphere, but people have repeated that experiment with oxidized atmosphere and they've got the same results, where you had a voltaic discharge and you had some water, and basically replicating what the Earth might have been 4.5 billion years ago. And he got the building blocks of life. He got nucleic acids. Later on, when people repeated his experiment, they got amino acids, they got HCN, they got HCHO, primitive molecules. And then one thing led to another, and then we had what Jacques Jostak, who incidentally got the Nobel Prize for something completely different, but who's been working on how life evolved on Earth. He got it on telomeres. And he figured out that you can actually make protocells that do not have any genetic information inside, but because of osmotic pressure and what is called the Donan effect, they can actually divide and replicate. And you can have these primitive cells that are formed at hydrothermal vents, where you can have nucleic acids being formed by combinations of HCHO and HCN. And slowly from there you come to what is called the RNA world. So the DNA does not exist, proteins don't exist, just these nucleic acids like RNA exist. And then comes along, I think Peter Czech, who solved this chicken and egg problem that was the great atlas for biologists. Which came first, chicken or egg? Which came first, protein or DNA? Because you need DNA to make protein and you need protein to make DNA. Until he figured out that there are things called ribozymes, that neither DNA nor protein came first, it was the RNA that came first. RNA can fold into a shape that can do catalysis. And that is the reason why ribosomes that make proteins in our bodies, they are 80% RNA. And so we know how life evolved from the basic building blocks. And I've talked about Stanley Miller, I've talked about Jacques Jostak, and then came a remarkable simple experiment called sexual PCR, Welbeck, William Stemmer, where he was able to show that within a space of 1 hour, you can accumulate mutations, helpful mutations, that can allow a resistance gene to combat a resistance of antibiotic 1 million times stronger than what it was capable of 1 hour ago. So that is essentially gave birth to what we call directed evolution, that it's taken 14 billion years for us to be here, but it can take 1 hour for us to combat a stress through selection. And then finally in the 90s came the genome sequencing, when the genomes of hundreds now of organisms were sequenced. We found out that it's not just the chimpanzee with whom we share 99.4% DNA that is identical DNA. It is that there are at least 10 to 15% of proteins that are found that are identical in all life forms. They are housekeeping proteins, housekeeping genes. E. coli has it, we have it, every organism has it. That all points to, you see what I'm doing here, I'm doing a big bang but of biology. I'm going back to where everything was, there was almost nothing. and then from there life has evolved. And now I see only humans trying to rationalize, trying to reason things out, trying to find a purpose in life, when we are just one of the life forms that are hanging on to this tree of life that has a million branches. There are organisms that are so much more successful than us. E. coli is more successful than us. We are given a stress, most of us will die. Within 5 years of a stress of antibiotic, you have E. coli or organisms that are able to develop resistance to it. Every antibiotic known to man. So, why, as Dr. Pandey said, science of course teaches us humility, but I think this book and hopefully volume 2 that would come out of this treatise will go beyond just teaching us humility of our insignificance. It will tell us that we are all in the end Camus Sisyphuses. We honestly are. There is no purpose. And all we do is push a rock up a hill and the rock tumbles down, and the next morning we do that, and somehow we feel happy or sad, but we need not feel anything. A bomb can fall right now, all of us will be destroyed. It doesn't mean anything. Try and zoom out of this room. Where would you end up? Amongst trillions of galaxies with trillions upon trillions of planets with trillions upon trillions of life forms. Everything is so inconsequential. So when we try and rationalize things, try and fit things in this jigsaw, I think the conclusion that at least I can draw is that we are allowing ourselves to be pranked, that life truly has absolutely no meaning whatsoever. Thank you. As I said, I have nothing to say, but I've said what I wanted.
Thank you, Professor Ranganathan. Nature, whether in a galaxy or in a genome, rewards the same spirit of fearless inquiry. Science also finds its highest expression when understanding is transformed into human well-being. Professor S.V. Ishwaran's work, from the discovery of molecule Visamin to pioneering research on lanosterols-based compounds for delaying cataracts, beautifully exemplifies this union of fundamental science and societal benefit. Professor Ishwaran is not able to join us in person today. He has kindly sent a video message which we will now be playing for you. Thank you.
Can I just add that Professor Ishwaran was my teacher in college, so for my inadequacies you can please blame him.
When I say a few words regarding the book written by Dr. Mrittunjoy Majumdar, whom I have known since 2011, when he joined St. Stephen College as a student of BSc Honours Physics. He has done very well since then. Let me focus on the book in the few minutes before me. I'll divide it into 3 parts, mostly taken from the book, but some of the parts may be a little beyond. The first title or subtitle I like to speak about is Annus Mirabilis. There was this young patent clerk who wrote some papers around 1905. Didn't make him a celebrity overnight. Many people did not accept his views. He famously said, "Be glad of your calm days when no one seems to notice you. Believe me, it has its good side. It is better to be an enlightened spectator rather than idiom in the actor." He further said, "At least in my case, these are some transient figures that appear before me, with which I am able to associate some kind of a permanence relationship, and at least in my case, the spoken or the written word is at best secondary process. This is none other than Albert Einstein. His views were discussed in a Solvay conference, as Mrittunjoy tells us, 1927. Some of the greatest physicists, scientists met there and clashed with each other. 1939, there was some supporting evidence. But I like to quote from this book that thus light bend near objects with very strong gravity. What is the problem with the GPS satellites? Why they have to be corrected from time to time? What is this relationship between space and time? There is much discussion. The recent past was not mentioned in the book about an interstellar object that came and went past Earth, Venus and Jupiter and Mars and so on a couple of months ago. There were questions asked which were not appreciated. The book wants us to be not too sure about things and tells us the absolute versus the uncertain. I do not know most matters do we want to be very absolute and sure about things. It is said that when we refer to our close relatives, we refer to them as relatives. We don't refer to them as absolutes. That itself tells us that there is nothing that remains permanent. But it does not mean, though the conference possibly eventually destroyed or shattered the glass house of Newton. I do not know. I know that there is this Schrodinger cat mentioned in the book. There is this, Newtonian apple, but I am yet to find the rabbit in the book. The question remains that these are celebrity papers recognized as the time went by, and today we understand even in the days of space travel, Einsteinian views are valid. But this doesn't mean that Newtonian views have completely been replaced. In some situations, as the author mentions, that quantum mechanics takes the, he says MRI is quantum mechanics, GPS is Einsteinian. Anyway, such hard divisions apart. So my view is that let us be a little open, especially when the title of the book deals with the word universe, not with the world. And that means we have to have not a world view, but a universal view. I quickly switch to the second major subtitle of my minds. Beyond the central dogma of life. Mrittunjoy puts it in very simple words. DNA makes RNA, RNA makes proteins, proteins make life. But this central dogma, is it to be questioned or is it to be accepted like a sutra or a chanting from the Bhagavad Gita or say one of the Vedas in India, which are sacrosanct? Is the central dogma sacrosanct? He finds no reverse runs to place opposite the apple cart. And today we know, I am going to question this a little beyond. That's why God beyond in my subtitle, beyond the central dogma of life, the question mark. In recent years, briefly stated, I have isolated Valpahadi acid from the soil of Valpahadi near Gurgaon. I have isolated kilograms of a new non-protein organic amino acid from a source in Tamil Nadu. I have isolated new non-protein organic amino acids from Gazipur, the infamous Gazipur landfill. This is not to mean that the phrase means that these are not used to make proteins. I mean to say these are not known to make proteins on Earth. At least we have not seen. But why this adherence to the 5 nucleotide bases and a 21 or 22 amino acids? I have expanded my view and there asked, can there be other nucleotides? There we asked, as I asked, are there possibly other amino acids which could also be incorporated into life? The 2024 Nobel Prize in my subject went to 3 people who developed AlphaFold 2.0 and so on, with which they were able to predict the shapes, 3-dimensional shapes and so on, all known proteins and went far beyond. Suppose we replace one of the amino acids by another amino acid. Will it remain an anti-diabetic? I'm not too sure. I quickly leave and take the third topic of mine, which is dark matter, dark energy, mentioned towards the end of the book. Allow me to chant. Kripadurva Purnai Purushaha Vado Syeha Hava Punaha Ato Vishvam Vyakramat Sashana Nashkane Avi. Goes on like this, part of the Purusha Suktam, which is chanted in India on holy occasions, on good occasions, not so happy occasions. It is a very sacred mantra.
Thank you, Professor Ishwaran. Your reflections remind us that the deepest science often finds its fulfillment in improving human life. Thank you.
Our understanding of the universe begins not only with the distant stars but also with the air we breathe. Dr. Sumit Mishra's research on atmospheric particles, climate, air quality, and precision measurement remind us that even the invisible shapes our lives in profound ways. Unfortunately, he is unable to be with us because of some personal medical issues. He has very kindly sent us a statement which I would now request Purnisha to read on his behalf.
Good afternoon to all. At the heart of every scientific breakthrough lies a simple question: how well can we measure it? Every scientific measurement carries a degree of uncertainty, and every instrument has limits to its precision. Far from being a weakness, this is one of the greatest strengths of science. By quantifying uncertainty, improving accuracy, and continually refining our measurements, science steadily builds a more reliable understanding of the natural world. This philosophy of continuous improvement lies at the heart of measurement science, where confidence is built, but not on claims of absolute certainty, but on rigorous experimentation, traceability to international accepted standards, reproducibility of results, and transparency in reporting. It is this commitment that enables institutions such as the National Physical Laboratory to provide the measurement foundation upon which science, technology, industry, and public policy depend. Now, here, this is more important than in addressing climate change and environmental pollution. The Earth's climate is an extraordinarily complex system in which the atmosphere, ocean, land, ice sheets, ecosystem, and human activities continuously interact through countless feedback mechanisms. Similarly, pollutants released into the environment do not remain confined in a single location. They travel through air and water, undergo chemical transformation, accumulate in ecosystem, and often produce effects far from their original source. Understanding this interconnected system is only possible through precise, long-term, and international compatible measurements. Satellite observation, weather station, ocean monitoring networks, laboratory analysis, atmospheric measurement, and advanced environmental sensor together provide an increasingly complete picture of our changing planet. Their remarkable ingredient gives us a high confidence that the earth is warming, that human activities are the primary driver of recent climate change, and that pollution continues to pose significant risk to both ecosystem and human health. As measurement technologies become more sensitive, scientists can detect emerging contaminants, identify subtle environment changes, and deepen our understanding of processes that were previously beyond our ability to observe. Better measurements lead to better science, and better science lead to better decision. Scientific uncertainty should never be confused with ignorance. Rather, it defines the range within which our knowledge is established and the confidence we can place in it. Every major technological achievement, from precision manufacturing and advanced healthcare to aviation and space exploration, depends upon understanding and managing uncertainty rather than pretending it does not exist. Environmental science follows the same principle. Sustainability is not a fixed destination or a single universal solution, but a continuous process of learning, monitoring, innovation, and adaptation. As new evidence emerges, our observational capabilities improve. Scientific understanding becomes more refined, enabling policymakers, industries, and communities to make better informed decisions while remaining responsive to changing environmental conditions. Environmental decisions cannot wait for absolute certainty, particularly when the consequences of inaction may be irreversible. They must instead be guided by the best available evidence built on accurate measurement, continuous monitoring, and internationally agreed standards that evolve as new knowledge emerges. In this sense, measurement is far more than a scientific exercise. It is the foundation of informed environmental stewardship, evidence-based policymaking, and our shared responsibility to build a healthier, more sustainable future. With that, I conclude Dr. Sumit Mistra's thoughts. Thank you all for your kind attention. It was truly my pleasure to deliver these words before you. Thank you.
Thank you, Nisha and Dr. Mishra. Precision in measurement has always been one of science's surest paths to deeper understanding. It is now my pleasure to invite Dr. Arun Pratap Sekawar, Associate Professor at NCERT, a researcher in biotechnology, molecular biology, and biomedical sciences. He has combined scientific inquiry with deep commitment to education and science communication, helping bring the spirit of science to both the classroom and the wider public.
Okay, thank you. It's my pleasure to be with you all intellectuals here. I'm so thankful to go through this book, The Universe is Pranking Us, from my friend Dr. Mrittunjoy. Before me, from the biology background, Professor Anand has already spoken a lot of exceptions in biology. Being a biologist, I think of that from physics, chemistry, maths, probably biology is having maximum exceptions. And the more we try to understand biology, the more exceptions keep coming. Now, my predecessors have talked about the central dogma, like DNA to RNA to protein that we were coming up. Now, we should remember, like last 20-30 years, we have come across with prions, that is the faulty protein that can create the disease. It is being mentioned in this chapter 5, that bioabsurdity. And my first cousin, just 6 months before, she passed away with this prion disease in Delhi. She was living here. So I was so stunned when the report had come for the prions. Similarly, there are a lot of exceptions and अनेकांतवाद, जो जैन philosophy का part है, कि किस तरह से whatever and how much we know day by day, the more questions keep coming. So we are not satisfying with the answers whatever we get more and more. Now artificial cells of J. Craig Venter, and now just Professor Anand also told this morning in the newspaper, now the protozoal and artificial cell, and now everything will be coming up. I'm having some experience of neurobiology during my 3 postdoctoral associates. So I come across that among all the medical sciences, neurobiology is the least studied. Among them, there are a lot of enigma and a lot of unanswered questions keep coming. Now, recently we have come across over the TV channels, you might have seen those videos where two great leaders of country they are talking about longevity. They were thinking as if they want to live more than 100 or 150 years. Now remember, the perpetuation of human memory, perpetuation of human living, they are talking about also. Humans are also like trying to carve for how they can extend the life. Similarly, now things are coming up where the dead man memory will be captured over the cloud, over internet, and then it might be able to transplanted over another human being, so that perpetuation of person might be there. There are a lot of examples, especially Lynn Margulis' example is beautifully mentioned by Dr. Mrittunjoy, that how serial endosymbiotic theory led to, that our eukaryotic cell is not the property of one single individual, rather it is having bacteria that was probably came up from, unicellular or prokaryotic cell to help this eukaryotic cells by which we all have come across. So lot of things we have read here, listened here. I will stop because we are running a bit late. Thank you so much.
Thank you, Dr. Arun. Every scientific discovery ultimately finds its true meaning when it inspires the next generation to ask better questions. Science is complete only when it enters public life. Dr. Kamalika Banerjee has devoted her career to building bridges between scientific discovery, public health policy, and society, reminding us that knowledge achieves its fullest purpose when it is shared with clarity and compassion. It is my privilege to invite Dr. Banerjee.
आप सभी को मेरा प्रणाम। इस किताब के लिए मैं डॉक्टर मृत्युंजय गुहा मजुमदार को बहुत बहुत शुभकामनाएं देती हूँ और मेरे को इस मंच में आमंत्रित करने के लिए बहुत आभार। मेरे शब्द आप तक पहुँचे, मेरा यही सौभाग्य है। Have you ever washed your car only for it to rain 10 minutes later? Have you ever run late for an important meeting only to get stuck behind a tractor on a single lane road? Or maybe you finally built up the courage to text your crush only for your phone to autocorrect a normal word into something completely unhinged. In those moments, you can't help but look up at the sky, look for a hidden camera, and realize one undeniable truth: the universe is pranking us. It feels personal, doesn't it? It feels like there's a cosmic director sitting in a control room, eating popcorn and throwing minor inconveniences at us just to see how we react. We spend our entire lives trying to plan, schedule, and control our futures. We make 5-year plans, we use calendar apps, and we rely on logic. And yet, the universe consistently looks at our neatly organized plans and says, "That's cute, watch this." But here is the fascinating part. This isn't just a bad luck or a bad day. It turns out science and philosophy actually back this up. In his book, The Universe is Pranking Us, this maverick, Dr. Mrittunjoy Majumdar, my dear friend, points out that at the very deepest level of reality, quantum physics, the universe refuses to be predictable. Subatomic particles can literally exist in two places at once. They change their behavior the moment we try to measure them. Reality itself thrives on uncertainty, paradox, and mystery. So if the very fabric of our universe is built on unpredictability, why do we expect our daily lives to go perfectly according to plan and logic? I live with a prank myself. My husband, Swapnil Tiwari, calls himself a madman. He's a dyslexic and a synesthete. What is synesthesia? Synesthesia is a sensory prank of the universe. Senses are mixed. What one sees is what also one smells and tastes and listens to. So imagine that you are watching the sky but you are actually able to smell it, or you are able to see the sun and you want to eat it. He's probably smelling this peach as well right now. One thing that I would like to talk about is the chaos that lies at the crux of our existence. Scientifically, when we talk about the Brownian motion, the dust particles and they're moving everywhere, that reflects the Brownian motion, or like Professor Anand Ranganathan mentioned about the Miller-Urey experiment. If you also look into the nature, the chaotic movement of river, which also breaks down systematically or unsystematically the borders and creates a regular path for it to reach its destination, which is not planned and yet it is planned, and that is its destination, the ocean. And so randomness could become the new normal. When Samudra Manthan happened, the expectation was that Amrit would come out of it. However, nobody expected that Vish would also come out, for which Lord Shiva was called. So when even the gods are not protected from the Vish and the other aspects of Samudra Manthan, how can humans be protected out of it? And so Manthan ही हमारे जीवन का सार है. And finally, the prank that Dr. Guha Majumdar is talking about isn't a punishment. The prank is a reminder. It is a reminder that the illusion of total control and logic is exactly that, an illusion. When we fight against the chaos, we get stressed, angry and miserable. But when we lean into this absurdity, something amazing happens. We start to laugh. The next time the universe pulls out the rug from under you, don't ask, why me? Instead, smile and say, okay, you got me, I'll try. Because the secret to surviving this wild, unpredictable life isn't forcing the universe to make sense. It is learning to appreciate the punchline, embracing the uncertainty, and accepting the prank that the universe is playing with us. Thank you.
Thank you, Dr. Banerjee. Your reflections remind us that science grows stronger when it is communicated with both rigor and humanity. We now go to a scientist whose work spans accelerator physics and plasma physics, fields that continue to shape our understanding of matter under some of nature's most extreme conditions. Dr. Sarvesh Kumar's work reminds us that the pursuit of fundamental science is also the pursuit of deeper questions about the universe itself. May I request Dr. Kumar to offer his reflections.
नमस्कार साथियों, मृत्युंजय जी को बहुत बहुत बधाई एक ऐसी बुक लिखने के लिए जो कि हमें वास्तविकता में एंशिएंट साइंस की तरफ ही ले जाने वाली है. ये मेरा फर्म बिलीफ है. और धीरे धीरे हम साइंटिफिक एटीट्यूड में, जैसे हम एक प्योर फिजिसिस्ट हैं या प्योर बायोलॉजिस्ट हैं, तो हम इस बुक को समझने के लिए हमें एक स्टैंडर्ड आइडियोलॉजी या फिलॉसफी से हटकर सोचना होगा, जिसमें कुछ एंशिएंट फिलॉसफी के भी कंसेप्ट शामिल हो सकते हैं. तो एज ए फिजिसिस्ट मैं क्या सोचता हूँ, मैं इससे उल्टा सोचता हूँ कि यूनिवर्स इज़ नॉट प्रैंकिंग अस. It is simply under no obligation to match human intuitions. But as a philosopher, I think like Mrittunjoy ji. So, but I believe that physicist and philosopher has to come together to make this book more advanced and advanced. And just think about it. Mrittunjoy ji और मेरा एक और दोस्त है जिसका नाम यूनिवर्स है. ये यूनिवर्स इतना इंटेलिजेंट है कि जब हम इसके साथ पहला हैंडशेक करते हैं तो ये हमें अपनी एब्सोल्यूट चीज़ें बताता है. जैसे स्पेस एंड टाइम के बारे में हमें लगता है सब कुछ एब्सोल्यूट है. हम घर से चलकर आए हैं, स्पेस एब्सोल्यूट है. इतने टाइम में पहुंचे हैं, स्पेस एब्सोल्यूट है. बट वही बात अगर आप LHC में, लार्ज हेड्रोन कोलाइडर में, जो प्रोटॉन दौड़ता है, जो 27 किलोमीटर दौड़ता है, उस प्रोटॉन को लगता है कि उसने 27 किलोमीटर नहीं दौड़ा है, बल्कि उसने सिर्फ 4 मीटर का डिस्टेंस ही तय किया है. तो ये स्पेस टाइम की जो रिलेटिविटीज़ के कंसेप्ट है, ये एडवांस हैंडशेक में यूनिवर्स हमारे साथ प्रैंक करता है. और ऐसे देखने में आता है कि पार्टिकल की प्रॉपर्टीज एब्सोल्यूट है, बट क्वांटम मैकेनिक्स सेज दैट इट हैज़ ड्यूअलिटी नेचर. और तो हम सोचते हैं कि ऑर्डिनरी मैटर हमारा सारा का सारा यूनिवर्स में भरा हुआ है. बट देखा जाए तो साइंटिस्ट जैसे जैसे और ऑब्जर्वेशंस लेते हैं तो हमें डार्क एनर्जी और डार्क मैटर के एक्सपेरिमेंटल एविडेंसेस मिलते हैं. तो यूनिवर्स इज़ pranking us or not pranking us depends upon our how much friendship we are doing with the universe, as a very nice friend, as an intellectual friend, as a ancient philosopher friend also. So I believe that his book will break through our ancient concept also for Indian science, will take us towards that. And I congratulate him again and again for this wonderful book, and wish him a very best success in the future. Thank you so much.
Right. So, good afternoon to one and all present here. It's lovely to have such an august gathering here. We have heard from some very eminent luminaries cutting across different areas of science, of the sciences. And there were some observations. First, I would like to kind of go over those, if you don't mind. Yeah. So the first one, which I think was highlighted by Dr. Ranganathan and Dr. Sarvesh Kumar as well, it's all about the perspective, right? I mean, it's all about how we look at things, how we formulate, how we conceptualize the different aspects of reality itself, and what are the bounds, what are the various constraints that we have to take into consideration before we do what is called as uber rationalization at various points, or going with a certain kind of framework or construct beyond and besides what is found in empiricism within different experiments that we have in physics, in biology, in various other places as well. I'm deeply grateful to our distinguished speakers for the wisdom that they have shared. They have brought forth these questions that have cut across these disciplines, the generations that have come and gone. And however, I would like to kind of focus a little bit on the various nuances that came forth when I was writing this book, that kind of sprung or germinated the whole premise of this book itself. And there was one point I heard during the discussion, which was about life, about how we look at the different aspects of life and how it comes about. During my postdoctoral stint at Harvard University, there was a work on non-equilibrium thermodynamics, and as we speak, there is an attempt to look at different kinds of chemical reactions, such as the BZ reaction, to try to replicate or see different traits of life, be it that of locomotion, be it that of synthesis of different resources, or even of evolution for that matter. I would be happy to share with this August gathering that recently, actually a couple of days back, there has been a paper that has been published with Professor Brian Josephson, who has very kindly kind of given the foreword for this book as well. And he was one of the youngest Nobel laureates, as you all may appreciate. In 1973, he got the Nobel Prize for Physics. And the paper is about moving beyond the theory of everything, right? Moving beyond this premise of the theory of everything. And I'm happy to share that will also be presented at the Lindau Nobel Laureate Conference that this year, which is being conducted as we speak around this time. So that definitely, I hope, will lead to further discussions on the premise that this book has brought forth. So I would like to begin with a small confession, right? I mean, this book started with a conceptual crisis, right? And we have been talking about conceptual crises. And I'd spent years immersed in quantum physics, in mathematics and the foundations of the sciences, convinced that if I dug deep enough, I would find this solid ground, right? I would find this unshakable foundation that everything rests upon. And in doing so, I actually thought that I'm probably following the path of one Albert. And if I may have one of the PPT here, yeah. So the Albert I'm talking about is not Albert Einstein. I'm talking about Albert Michelson, right? Albert Michelson, who famously predicted or said that the future truths of science are to be held or found in the 6th place of decimals, right? And he was talking at the 1894 speech at the dedication of the Ryerson Physical Laboratory in the University of Chicago. And it's funny because there is this idea that there is a hubris almost, there is an arrogance of sorts in terms of the fact that the framework has been developed. It's about the application, it's about the precision of application of whatever already has been found. And that itself was broken, was dismantled summarily by another Albert, right, in about 11 years' time. So 1894 is when Albert Michelson talks about this. And then in 1905, as Dr. S.V. Ishwaran very beautifully put, we had the Annus Mirabilis, right, which is the year of miracles. And do we have the slides here? Can you please present it? Can you go forward, please? Yeah. Next, please. Yeah, if you go to the the sixth slide. Yeah. No, you can just go to directly to the sixth one. Later on. You can just. Yeah. Okay. So that's Albert Michelson right there, right? And he's very well known for the Michelson-Morley experiment as well, which was one of the the seminal way in which ether, the idea of ether or luminiferous ether, was dismantled with the drift, the aspect of drift, which should have come into being with the velocity of light. So it was an optical kind of experiment, and that was obviously dismantled, this idea of ether itself. If you go forward, please. Okay, so that's Albert Einstein, of course, and those are actually the original screenshots or the current screenshots of the 4 papers. And I think Dr. Kamalika mentioned about Brownian motion. So he in fact did write the 4th paper, which not many people talk about, which was on Brownian motion in 1905 as well. And so the idea is that the history and nature has this way of playing tricks, right? The trick is the certainties of one age become the curiosities of the next, right? And the more I searched for absolute certainty, the less I found it in various places, including in the application of quantum physics, of course, and quantum field theory, and going into logic structures that came forth from this application of this realm of physics that we're talking about. And then I had the realization that the search for absolute certainty isn't just difficult. It may just be fundamentally misguided in certain places, right? I mean, we live in an age drowning in answers, right? I think Dr. Kamalika mentioned about this. 5-step formulas for success, right? Algorithms that predict your every preference, right? There are these self-help books that promise enlightenment by the next Friday, probably, right? I mean, everyone claims to know, right? I mean, truth peddlers, there are fame-hungry influencers, boisterous public intellectuals. They all whisper the same beguiling kind of promise, which is be sure, be right, be done, right? But what if this universe, the universe that we exist in, if some of you are, multiverse proponents, then so be it, right? The universe we are in gives a wry smile every time we display our adorable human needs to be sure to be wrapping reality in these neat little packages, so to say, right? What if the cosmos is playing by completely different, counterintuitive rules, so to say, right? Rules that may change midway, rules that may contradict the premises they are built upon, rules that are fairly fluidic in certain regimes and conditions themselves, right? So my book, The Universe is Pranking Us, explores this premise, the magnificent and the beautiful realization that our entire quest for the ultimate truth may be highly highly kind of conditioned to this concept of contextuality, to the concept of having contingent realities as we speak about, right? So now let me take you back a little, and I'll be oscillating like this in history, and I like to do that. Let me take you to the autumn of 1927, right, in the ballroom of Brussels, and I think Dr. Ishwaran mentioned about the Solvay conference which happened, and there were 29 people out there at that point in time. 17 of them were either, and there you have it, 29 of them, right, fairly, big in their own ways in different areas of physics. And 17 of the people that you see out there were either Nobel laureates by that time or would be Nobel laureates in the years going ahead. So as they sat together, they found themselves standing at the edge of a terrifying paradigm shift, right? And the paradigm shift was, for centuries, science believed that there is a vast, predictable universe that we have around us, right? A deterministic automata, if you will. Objects had definite properties. There were different ways in which you could know about the state of the system if you already knew what the state was at this point in time, and you could predict, for instance, in a very definitive way what the state would be in a future point in time. But when scientists looked into the subatomic level, we see that there are different areas of this world that we talk about, and I think Dr. Kamalika mentioned about this, that different states can exist, for instance, or coexist in a multiplicity of possibilities till this point of interaction with the measuring device, so to say, right? Now, I would like to tamper this with a little bit of caution, essentially, because we often talk about consciousness, we talk about how we undertake this observer effect. And I've been very careful in this book as well as in my previous book to delineate what I think is scientifically permissible and what is not, essentially, right? So here I do mention that the observer effect is very much in place, although the Wheeler-Wigner aspect of consciousness is not quite as it is as it stands today. So we have to be very careful about that as well. So the Solvay conference of 1927 was also the starting point of a wonderful, epic intellectual clash, right? Among, well, you can't see Niels Bohr, I think, or maybe you can, and Einstein is right there. So Niels Bohr and Einstein, for a good 8 years, from 1927 to 1935, had a series of different kind of correspondences. Those of you who are interested could definitely have a look at that. And the idea was that Einstein was deeply uncomfortable with this aspect of the probabilistic universe, right? The universe having the different possibilities, the ways in which things can evolve. And he said that maybe there is a hidden variable somewhere that we do not know about, right? There is something that we are not completely aware of. And he famously, of course, said that God does not play dice, right? But then Niels Bohr came forth with this idea that, well, what if, you should not be dictating to nature what it should be doing, right? I mean, what if nature is like that, right? And you have to just make do, right? You have to deal with this reality as it is, and not quite kind of go into, again, as Dr. Ranganathan mentioned, about rationalizing it in the ways that you are familiar with, essentially, right? I mean, beyond a point, right? So now the reality isn't made of isolated things per se, right? It's a whole flux of different materials, and the lines where the systems exist and don't exist themselves get blurred quite a bit as well, right? So the profound paradigm shift that happened in 1925, and last year the United Nations, we have the United Nations office very close to here, celebrated the International Year of Quantum, right? And I mentioned that 1905 was when we had Einstein come forth with his papers. So I would like to ask all of you, why do you think that we celebrated the 100th year last year then? Isn't 1905 to 2025 120 years? I mean, why did we do the 100th year as such? And yes, but the 100th year was 2025, right? Last year, the International Year of Quantum. Yeah. Yes. Yes, exactly. So there is a transition from the old quantum theory to the new quantum theory, which took place in 1925. And if you can go to the next slide, please. I just wanted to show you a fascinating piece of this is a Heligoland island, right? And Heisenberg actually went to this island because of hay fever, right? He was suffering from hay fever, and just like we were told ki aap thoda sa pahad ghum ke aiye and have a little bit of fresh air, he was told to go to this island, and he was thinking about radiation spectra and various other aspects, and how things don't kind of commute, or when you change the order of experimentation, it affects things, right? So in a way, you can say that Heligoland, well, it's a little bit of a overextension, is a kind of the germination point of sorts of the new quantum theory, which led to the 100th year happening last year as such, right? I wouldn't go into the biological aspect all that much because we have luminaries here who have already mentioned about it. But again, Darwin talking about species, the concept of species itself, in his letter to Sir Joseph Dalton Hooker on the 24th of December in 1856 said that we're trying to define the undefinable probably, right? I mean, there is a whole way in which we define what are species, what is this constant flux of matter and form that takes place, and how do we conceptualize this concept of species itself. He gives a beautiful commentary on that, and you can see here an illustration of the HMS Beagle surveying the coast of South America. And Darwin theorized about geology and extinction of mammals. This was made by Conrad Martins, who was a ship's artist after he replaced the artist who was taken from their home ground, and there was a replacement in the middle. So Conrad Martins was a second artist on the trip as such. Now Kurt Gödel, we talk about Kurt Gödel in mathematics and this idea that he proposed, which is that no logical system as such can have statements all the way which are capable of having provability within itself, right? I mean, if you can state something within a formal system as such, there is always something which probably cannot be explained within that formal system itself, right? So Kurt Gödel comes up with this idea, and a very interesting kind of application of this is a liar paradox, right? The liar paradox, which says this statement is unprovable within the axiomatic system I am using, right? Within the system I am using as such. So if you say that this is false, then you are in a problem, right? And if you say it is true, then as well, right? There's something called as a liar paradox that comes into the picture. So if the system proves a statement, then it becomes logically inconsistent, right? But if the system remains unprovable, it is mathematically true, right? So there are these beautiful paradoxes that take place between different mathematical frameworks and in physics as such, right? In cosmology, we are talking about stars and galaxies and planets, but they are just 5% of the universe, right? They're just 5%. I mean, 95% of the universe is composed of, I think somebody mentioned about dark matter and dark energy, right? And so I'll come to that. Before that, if you just go back a little, yeah. So Kurt Gödel was also just one slide back, yeah. Yeah, so Kurt Gödel was also the first Albert Einstein awardee, right? And you can see Albert Einstein here, and he's also Julian Schwinger was the other awardee, and you can see Louis L. Strauss as well in present, attendance here as such. Now, going back to dark matter and dark energy, physicists, have an irreverent sense of humor, right? We often have ways in which we name things, right? Does anyone know what are the different candidate theories of dark matter as it stands? And they are very fascinating as such. Any thoughts? Yeah. Right. But the name, do you recall? Okay. No, not quite. Yeah. Anyone else? Yes, sir. Yes. Okay. They're called WIMPs and machos, right? So these are acronyms, by the way, right? Weakly interacting massive particles, right? And machos are massive compact halo objects, right? Now, after decades of looking, we are beginning to suspect that the names might be the most tangible things about this, okay? Because there is definitely not any conclusive aspect of this search that we talk about. We know that dark energy also exists because we have hypothesized that the accelerated expansion of the universe is driven by dark energy. But however, it is like deducing that there was an elephant in this room because the furnitures are all over the place, right? We have not found the elephant as such. We're just seeing things essentially, and it's not been proven at all, right? So JBS Haldane says the universe is not only queerer than we suppose, but queerer than we can suppose as such, right? So when I was writing this book, and I think my friends here, Dr. Sikarwar and Dr. Sarvesh mentioned about different aspects of the Indic knowledge, the Indian knowledge systems as such, and there is one word that comes to mind, when we talk about the universe is pranking us, which is anirvachaniya, right? Anirvachaniya, which is a Sanskrit word, which means that which cannot be stated, right? That which cannot be conceptualized, that which cannot be formulated even, right? So when we talk about the fundamental reality of the universe, right, somewhere maybe the questioning, the posturing, the positioning itself is the fundamental reason we are talking about things like the universe is pranking us, right? Because the very basis of what we are doing and how we are doing it is based on certain frameworks in terms of which we are thinking about this in the first place, right? So the whole idea of the universe being, a prankster, so to say, right, is also not cruel, right? The universe is not doing it because, forgive my anthropomorphism here, right? The universe is not playing a trick because of cruelty, right? It is probably teaching us this concept of humility, right? This and which I talk about in the book as well. The way to, live and survive and do well in this whole world where we talk about the universe pranking us is that maybe we have to understand that there are things which are contextual, that are conditional, and we have to be humble about the limits at which these constructs can go up to, essentially, right? And that is why this whole idea of my way or the highway, right? This idea that I am correct and you are not, which is often seen in the society that we exist in today, unfortunately, right, has to be somehow tempered with this understanding, this realization of where things are when we talk about the nature of reality in the universe as we see it in the universe, which probably is pranking us in if we look at it in that way. So the cosmos is vast, it is strange, it is very paradoxical, and so thankfully are we. And therefore, with this, I would like to kind of conclude, and I look forward to the question answers, the engagement with the audience in attendance, and I thank you all for coming out here today. Thank you so much. Yeah.
So, can I ask a question? Sorry? Okay. I am Dr. Manjushri Chaudhary, and I have been a facilitator of physics and a student as well, and say the Indian knowledge system, since my mother was a professor of Sanskrit in Delhi University. So, and I learned from her that in Taittiriya Upanishad, it says that, that words, they are reflected back, and even the mind is reflected back from reality as such, reality or whatever we call it, the power or the truth, and it is incomprehensible. So, thus, if that is so, that is that reality
is incomprehensible, and it is, transcending all the perturbations. These perturbations are words or sound or the cognition itself. And as all the luminary, the professors and the scholars over here have said, that whatever is there, whatever scientific theories are there, they are not absolute, and they are, changing all the time. Our perception is changing all the time. So is the universe pranking us because of the limitation of our cognition? Thank you.
Yeah, thank you for that question. And I think there is one thing which I, forgot to kind of mention, and which your question brings forth. Non-absolutism itself can be absolutist, right? This whole idea that we have to prove that nothing is absolute, right? And Buddha, Buddha says this beautifully in one of his interactions. There is this interaction where somebody comes up to him and says, "Is there a God?" Right? And he smiles, right? In the evening, somebody says, "Well, is there no God?" He frames it in that way, right? The follower, and he smiles again. Right? So this idea of what is stated, what is negated, what is to be absolute or not, right? Even that itself should be questioned. Right? So I'll give you an example. I'll give you a very tangible example. So in our physics community, we have been talking about the constants of nature, right? I mean, there is the speed of light, there are the fine structure constant, and so on and so forth. And many people are trying to see the variations in that, right? The variability, and whether they're actually quote unquote constants or not, right? Until now, we have seen that there is a sufficient degree of stability in the appearance of these constants. It's not that they are kind of varying beyond a point. I mean, in fact, fine structure constant has not been found to be varying all that much, right? So there is a degree of stability and coherence and form that we can talk about, right? And so it is not that it's all fluidic and all flimsy all the way, right? So the concept that everything is fluidic, everything has to be questioned, somewhere there is a contingent stability and coherence as well that we have to acknowledge, and that is very much present in the universe. So again, going back to the point, when we talk about absolutism and non-absolutism, both of them one step above in the meta level, if you will, should be questioned for their own absolutism as such as well, right? And it goes on in regress, it goes on ad infinitum in that sense, right? So it's something which is not conceptualizable. That's the word that is often used, right? Not to be formulated at all in certain constructs, so to say. So again, going back to your question, I think, yes, we are limited by the instruments of our cognition, the instruments of how we access that reality in the first place, and the basis, the frameworks we use to explain them as well, right? And so that is why probably the universe is pranking us. Yeah. Thank you. Yeah. Yes. Yes, please. Yeah, please. Yeah.
Traveling 27 kilometers. Yeah. Sorry. Thank you very much. It's been the most enlightening. I'm A.K. Merchant. I'm interested in quantum physics and the quantum entanglement issues. I wanted to know about the latest developments after the Large Hadron Collider gave us the evidence of God particle. What more has it contributed? And there was a reference made in the talk that the proton that's supposed to have traveled 27 kilometers actually moved only a few meters. What was that?
Well, there are, so Atlas...
4 kilometers?
Yeah. Atlas, LHC, yeah, there are a lot of different experiments, and in fact, LHC has now, I think Sarvesh ji will be very placed. Yeah, I think I'll defer to him actually for this. Yeah, go ahead, please. Yeah.
This was put up by me to realize you that relativity is a practical concept. It's not like we cannot have a spaceship running at the velocity of light and just board it and then feel the relativity. Feel the relativity by the protons traveling in the LHC circle. LHC circle is 27 kilometer, but in proton-ons frame, as a proton, I feel only 4 meters length. The same way, let us suppose if you want to look at the Mahabharata, there are many versions of Mahabharata, but if you, let us suppose I fix it, it is at 5,000 years before. So go at the 5,000 light years far away from the earth, the Mahabharatas, the pictures, visuals will be visible by the telescope which is sitting at 500 light years away. So for that person, Mahabharata is still going on. So what is absolute for us to be sitting on the earth? Mahabharata is not happening right now, but for that person Mahabharata is happening right now. So that's what I want to try to add on to his concept of absolutism and non-absolutism in time as well as in space.
Thank you, Yogendra Kumar. First of all, a very stimulating discussion. This idea that you have interdisciplinary panel to discuss something as profound as this, I think is a wonderful idea. I only hope there are some philosophers as well here, philosophers of Indian philosophers and Western philosophers, because I think even the national education policy talks about interdisciplinary sort of grooming of mind from very early age. My question basically is this, that pranks and all that is fine, but I think now we live in the world of post-reality as well. So one thing was synthetic cell which was mentioned, and I was listening to a talk which actually said it also bites. The other thing, of course, is that now you have the artificial intelligence, which now people talk about general artificial intelligence. Yeah. The question actually is this, at what stage do we have a sense as to when, let's say, the synthetic cell will become conscious, as we understand the word, self-aware, and also artificial intelligence, whether it would become self-aware at some point. Because if you see, how the artificial intelligence models are being trained, the questions being put to them to train that model are not the kind of questions you ask each other when you actually either grooming that person's mind or even having a discussion. Thank you.
Thank you for that.
One more thing here we talked about. In the Rig Veda, there is a famous Nasadi Sukta. It's very actually interesting. It talks about the period before the birth of the cosmos. And that's a subject of speculation not just by the Vedic philosophers, but even Islamic philosophers and Christian philosophers. So what existed before the universe came into existence. But what is interesting in Nasadi Sukta is that it suggests that the birth of the cosmos was an act of passion, it was an act of will. So whether that goes into the prank dimension. The other thing which actually says, the way it ends, it says, what existed we don't know. Only God knows. Or maybe even the God doesn't know. I mean, think about the profundity of things. Thank you.
Yeah, thank you. I think this is a question that right now may have multiple answers, so mine would be just one of them. I think very soon, maybe 15, 20 years down the line, we really would have no work to do. We have to find out. We should all be, in fact, scientists should be fired in about five years from now. Very recently, 6 months ago, 18 labs, they used LLMs to combine 5 elements. They made 41 million molecules. Out of that, they found out 24 were using the alpha fold, were binding to a protein of a pathogen. They synthesized 4 of them, and 2 of them came out to be the most potent antibiotics known to man against MRSA. Something that scientists used to do and take 50 years was done in 15 days. That's just one example. So everything that requires mental faculties is going to be taken over by AI. And it's not just that the scientists, their jobs are under threat. 36% of all CAs in Nordic countries are now, their work is done by AI. In our country, it will take longer because of complicated tax laws. So even AI would find it difficult to trump what many CAs do. But that's the future. Everything is going to be taken over. The only jobs that would be left for people to do would be the physical jobs, and there also you have robotics that is moving at a breakneck speed. I always use the analogy of the combine harvester. A century ago, you required 10,000 people to harvest a field of rice. Now, one combine harvester does it. Would any businessman worth his or her salt go back to employing 10,000 people, or would he employ a combine harvester? It's just logic. So this is the direction we are going, and it is, you cannot change this direction. Hence, we have to bring in, quite frankly, what do we do? That's the most important question. And there again, I'm sorry, I bring in this anecdote. I don't know whether it's true or not, but it's so reflective and philosophical at so many levels, and it's come back to haunt us in a circular fashion. There was this rich NRI who was speeding away on a highway to Patiala, and suddenly his car got a puncture and it came to a halt, and there was fields and there was one guy sleeping on a charpai under a peepal tree, and he woke him up and said, "Hey, repair my puncture." And he said, poor fellow, he was doing that, and while he was doing it, they got talking, and he said, "Why don't you build a shop out here? You know, you can have facilities." Said, "Usse kya hoga?" Then he said, "Well, then people would come and stop there. Usse kya hoga?" Well, you know, if there are punctures, then you would employ people who would be able to repair those punctures. Usse kya hoga? You would get prosperous and you would be rich, and usse kya hoga? Phir aaram se चारपाई लगा के सोना. तो मैं वो गाली में बताऊंगा जो उसने बोली, उसने कहा वही तो कर रहा था. This is what we are faced with, and we don't even realize it. And hence the question, can anybody tell me with certainty? I mean, I truly believe the purpose of logic and rationale that has come in, that is exceptional only to humans, is to make our lives more comfortable. You know, that's the purpose of science right now. There is no other purpose, I feel, in biology, to make vaccines, to save lives, to air conditioning, light, everything is to make humans' lives comfortable. And now the question, do we believe that people, the Jarawas in some island that is inaccessible to humans and their inventions, do you think they are uncomfortable? Do you think someone who does not have access to a medicine or air conditioning or lighting is uncomfortable? The entire purpose of science has been to enter into this rat race of training, to train your mind, to constantly come up with things to make our lives comfortable. And again I ask this question, those Jarawas who are there, of course they are comfortable in their own thing. Would they have come up with those 1,000 inventions and those formulas E equals mc square on their own? What is the chances that every great discovery that we know that we have accomplished would repeat itself in a completely different setting that is completely secluded from the rest of us? I think we are at a stage where, and when Sir said, I would have wished we need more, there were more philosophers out here. Well, we all need to be philosophers if we have to make sense of the world. Yeah.
Thank you. Thanks for the opportunity for me to, I don't know if there are questions or comments, and thank you so much for this wonderful, inspiring panel. I mean, there's a few questions I have, but I don't know how they're all linked or not. I couldn't do it like Professor Ishwaran, in 3 sort of compartments. But one thing I wanted to ask was, and this might sound extremely stupid, is what is universe? Because we've talked about universe a lot. Each one of you has talked about universe in some way or the other, but it's not. So then I started to think, what do we actually mean when we say that? And there's a degree, and of course I can think of quasars and pulsars and black holes and the solar system and Earth and protons and neutrons and all of that, but there's still some degree of vagueness or uncertainty when I use that term. I don't know exactly what that means, and maybe I can't know that, and that's what you're probably suggesting. But I also want to ask, where does universe exist? Right? I could see where it exists out there. I look at the stars, that's the universe. But it seems to me that a lot of what we call universe exists in my thinking, or imagination, or in this thing called thought. So I don't have a direct experience necessarily of quasars. I don't have a direct experience of the Big Bang. I know this conceptually and theoretically. And so I think we have to examine, and I want to get to another point by saying this, examine first of all the nature of thought and imagination, and the relationship between thought and imagination, thought and what we call universe, okay? And so therefore, I think it's very important, since your book is talking about us, and you've all talked about us, the human species, Professor Ranganathan beautifully, is where are we located in the universe? Or what is this aspect of the universe that all of you have been saying does the kind of rationalizing, wants to understand, the conceptualizing, the analyzing? What part of the universe is that? Because as Professor Ghatak said, talked about protons and how you can't really identify them, and then Feynman said, they're neither waves nor particles. Well, we exist of that too, right? Fundamentally. Then we must also be fundamentally uncertain in your terms, right? Human beings. For some reason, in our perception and our experience, we don't have that quality, which I find paradoxical. So if I take this, and by the way, I wanted to ask you why you call your book The Universe is Pranking Us. That's very definitive. You could have said, is the universe pranking us? And then there's some other things like, we're talking about epistemic uncertainty in terms of what we can know and can't know. But the minute you say things are uncertain, then there must be some, and you've already pointed to that, I think, in one of your answers, something certain. So that is in a dual or binary framework, which perhaps says something about the way we think about reality. So anyway, something or the other.
Yeah. Okay. So, the two things I mentioned, one is the universe, and why is it us? What is us, right? And why have I said it's pranking us, essentially, right? So, the universe itself, I mean, if I were to go with physics itself as it stands today, there are a number of different ways in which we define it. There are, very extreme kind of theories, like, for instance, that it's an holographic projection of different kinds of correlations in some theory space, in a very mathematical space. In fact, physics itself, today we talk about particles, like this concept of particles. You may know that, particles are no longer those bounded kind of, elements in space somewhere. We probably rather should be talking about indices and mathematical kind of properties, and just a bunch of them in space, rather than actually something definitive in the sense of a bound around it in that way. So the whole idea of the definition of a system itself has been brought into question in a big way, of course. And even in thermodynamics, for instance, we talk about how the surroundings and the system itself has a flux of energy, of matter, of form. So this concept of us is itself very fluidic, right? Number one. Number two, the universe as such, as I said, there are a number of different ways you can define it. And the reason that you have this limit, this bound, so to say, is because we do have an event horizon for the universe as well. There is a boundary from which we get the evidences, or you can say the radiation, the data that we get from it, and not quite beyond that, even if we were to have the best of kind of equipments and the best of space shuttles and so on and so forth. And in fact, what Heisenberg said, and you mentioned about epistemic kind of ignorance or epistemic uncertainty, it's not just that, right? I mean, even if you were to have the best possible equipment, let's say hypothetically, and we were to, spend $1 billion, a lot of billions of dollars, even then there is a fundamental uncertainty of simultaneous conjugated variables, right? Like position and momentum, energy and time, and so on and so forth. So there is something which is more ontological, if you will. Right, and so this epistemic aspect, right, has to be qualified to kind of look at that possibility and that reality as well, in a certain manner of speaking. Yeah, please. Yeah.
So there's really a sort of a prior uncertainty that we're talking about, a condition or a state,
yes,
or a ground,
right,
for the universe,
right,
that is prior to the kind of.
Well, I wouldn't go that far, because it goes into speculative territory, right? I mean, if you were to talk about, let's say, when we say before the Big Bang, what happened, right? I mean, Penrose says there was a big crunch, and then there was a Big Bang, and there's a big crunch, and so on and so forth. Now that is purely speculative as per a physicist, right? Because we do not have the data or the evidence, empirically speaking, to establish or negate that, right? So at a certain level, I can probably, align with you or not, right? But at the level of empiricism, I probably cannot, right? And I have to be honest to that.
Prior to empiricism.
Yeah. So,
like for example, Professor Ranganathan said, if you keep sort of examining life, then you come to this nothing, right? Where you can't really talk about nothing in terms of certainty or uncertainty. It's it's sort of prior to that. Right? But it gives rise to all of this.
Pure chance. I mean, when you say what is universe, I would say amongst the trillions of celestial bodies, you are sure to find one where the temperature and water, or some substitute of water, is able to give birth to these primordial molecules that then combine together and form a replicative machine. So for me, that's, I'm not looking at it from a physicist point of view because it's just too complicated and too weird. But again, that itself partly answers your question, that I'm settling down on something that my mind can explain. That also is weird.
Okay, thank you. Okay, I'll just take one more, please. Sorry, Sorry, sir. We have a short time.
Thank you.
Yes, sir.
You are Argoside, that's why you could spot me. Now, this has been a feast. Observations or questions. The title of the book gives the impression that the universe has a personality. If that were so, I have a question. Is there any relationship between the 20,000 children killed in Palestine and, say, the nature of proton, the principle of uncertainty and all that? Second, has the universe got a purpose? Why should it exist? What is the raison d'etre? What is the reason for its existence? And last but not the least, it has been suggested, I'm not sure whether it is correct, that the universe exists so that we can struggle to make sense of it. Thank you.
Yeah, I think there is no relation between flying quarks or protons to the children who are killed either through acts of terrorism or through other nations, humans killing each other. I don't think it's just human reaction, tribalism, animosity. We've seen that. But I think we constantly kind of forget, or maybe again it's very natural to us to forget the timelines crunch that happens. Earth is 4 billion years old after it cooled, our evolutionary time scale. Everything that we use and know around us right now is not more than 2,000 years old. Everything, perhaps less than that, 1,500 years old. Which is weird because humans, as we know them, have existed for 3 million years. So for 2.99 million years, they existed like any other animal life does right now. And suddenly, in the last 2,000, or I would say 500 years, we've kind of distinguished ourselves. We moved apart from the rest of the animal beings. You look at any animal form, we forced them to change their ecosystem or habitat, but it is almost as if they haven't changed their habitat for million years. It's just humans. We've changed our habitat, and changing of that habitat has brought wars and whatever, unfair killing of children everywhere. So yeah, it's just the human thing.
Very small.
We're running really short.
Just one sentence.
Okay, the last question. Please.
I think it is the internet which is the biggest invention in last 200 years, and it has the implication on universe. It's not affecting human body. Most of the birds have disappeared already, and how it's going to affect our brain? I think brain is becoming defunct in near future. So what's your implication of internet?
So can I answer that question? I think the greatest human invention is vaccine. If your lives weren't saved by medicine, you wouldn't be able to use the internet.
And in Europe, they are not using it. They have rejected it. It's a vaccine is in.
Okay, yeah. Right, thank you, sir. Yeah. So before we conclude, allow me to express my greatest, deepest gratitude to our distinguished speakers for the generosity of their reflections and the wisdom that they have shared this evening. I'm profoundly honored by your presence and your thoughtful engagement with my work and with this theme, which is very important, as we can clearly see out here. My sincere thanks to the India International Center, to Dr. Usha Munshiji and her team as well for graciously hosting this gathering. I would like to acknowledge the dedication and hard work of my team of scholars who have been working over time on this, Ms. Sakshi Kumar, Mr. Anchit Miglani, Ms. Onisha Rakshit, whose support has brought this to fruition as well. On a more personal note, I would like to thank my family, especially my very young daughter who's 5.5 months now, and I've dedicated this book to her, Anandalekha. If there is one hope I cherish for her, it is that she may always find the courage to ask these honest questions, the humility to embrace what you do not know, and the joy of discovering that the pursuit of truth is itself one of life's greatest rewards. Above all, I thank all of you for being out here. A book is complete when it is written, but it is truly alive. It truly begins its life when it is read, it's questioned, and it's discussed, and perhaps even disagreed with, as we have seen out here. The evening has reminded us that ideas find their fullest meaning not in solitude, but in conversation. Thank you for your generosity, your attention, and companionship for this inquiry. I wish you all a very good afternoon. Namaskar. Okay, we all have tea downstairs, if you could join us, please. And we have copies of the book as well, if you're interested in that as well. Thank you.